computer open. So, just to start us off, we're going to be looking at patterns shown in a more visual form. So we've been doing the patterns of numbers, we've been doing the patterns of shapes and things that lead to numbers. We're just going to see what it looks like when we have a graph. So it's all the same sort of thing. Okay. I've asked you this question. Arithmetic sequences are also called linear sequences. Can you tell why?
Because if you like graphed it out, it would make a linear line across the graph.
If you graph it, okay, you get a straight line. Okay? That's why they're also called linear. So do you want to write that down? If you graph it, you will get a straight line.
It's on the graph.
What?
Like the thing that you told us today.
Where does it say if we graph it, you will get a straight line?
Oh.
So arithmetic sequences give straight lines, but we don't always have arithmetic sequences. We have other types of sequences. What do you think will happen if we graph a different type of sequence that's not arithmetic? Okay, so an exponential increase, which is when you multiply every time, you'll get a graph that kind of goes up quicker. You might have seen that. Other patterns like quadratics and things, you get a U shape. Yeah, you get curves basically. So in an arithmetic sequence, can you remind me what an arithmetic how we do it, Abby?
Like you can find the amount that each number goes up by.
And it's always the same. Good. Have constant change. Yeah? If the amount it goes up by changes every time, it's not arithmetic. Then it's not. Now, like I say, on the computer program, you'll see several of these. Right? So I just wanted to go through it so you've got an example on paper first. So basically, you use the information in the graph to fill out the table. Same information, different form. So that word there, Ryan, is something to do with MYP. We look at forms, different forms. That's the same information but written in a slightly different way. Okay. So we've got to try and fill out these values from the graph, but I've said, is the information we want actually on the graph, or do we need to make predictions based on the information we are given? So, for instance, where do you think 0, 5 is on that graph? Right? It's as simple as, it's here, look. That point there represents, this line is the 0 for the input, this is the 5 for the output. So this point represents all the 1s, yeah? So what's the output for 1? We would go up to the line and we see it's 7, okay? So do we need to make predictions? Yes, we do, because a 2 is that one, and then the 3 is that one, but if we go up the 2 to find the point, it's not there. But do you already have a way of making that prediction?
The prediction is with each number it's going by 2.
Yeah.
So after 7 you add 2 you get 9.
Yeah, we know it's an arithmetic sequence. This is why I said, NASA, you know, this is why I said use the information your knowledge from before. It is just an arithmetic sequence, and we can see it goes up by +2 every time. So the next one is going to be 2, 9, and then 3, 11. Now you can, however you fit that on your table, you might want to write it on the side. Those values are not on the graph, but you know, that's what it's going to look like. Fill those things in. Write it down, should only take 2 seconds. And we can see, you know, we've done plus 2, plus 2. Okay, and now we're like, what's the rule? I've said down here, when putting a pattern on a graph, we use different letters. Instead of UN and N, we're going to use X's and Y's. So what would be the rule, do you think, Zoe? All right, so we'll start with UN equals 2N. Good. Not plus 3. This is where it changes slightly. Remember, we've never had a 0 before because the first number in a sequence is, the first number is 7. All right? So 2 lots of 1 is 2, so we actually need to add
1.
No.
4.
Nope,
0.
nope,
1.
nope. Listen to each other because that's what I said.
5.
5. If I write this the way you're used to seeing it, look, it would be 1, 7, 2, 9, 3, 11, yeah? If n was first number, second number, third number. So we know it's plus 2. So it's going to be 2n, and what do you add on? Add 5. Now you might go, oh look, if I have a 0 and the 5, well, is that actually the number that I have to add on? It is actually. Another way of finding what I add on is to go to 0, because what's 2 times 0? 0. How do I get from 0 to 5? Add 5. Now, un equals 2n plus 5, but I've said down here, well, when we do it on a graph, we use x's and y's. So what's it going to be? Instead of un, we are going to say y equals, it's going to be 2x plus 5. Because as a function machine, we've said we have an input, we have a function machine which would do times by 2 and then plus 5, and what comes out is the output. So the input is, if it was n, it would end up being 2n plus 5, yeah? But if it's an x, it would be 2x plus 5, simple as that, okay? Yes?
So, I use a textbook and I go over the computer.
Yeah?
So we were doing, we would find out what x equals, and then we would, times it by the number to get the product. That's, I don't remember the exact steps, but we did something like that.
I think maybe that's something slightly along the same lines but different. What we're trying to do in this task is fill out the gaps and find the rule, which is basically what you've been doing anyway. Yeah? I think what you're saying is something like figuring out what the output would be if I told you what x was. Yeah? So for instance, we could say, what if I put 2 in, what comes out? 2 times 2 is 4. 4 plus 5 is 9. And then you'll see, look, in the table, it's 2 and 9. So it's all linked together. Yeah? All right. How do you feel about that? Yeah? Yeah? Let's have a look at this one together. Okay? All right, the 06175. Now, sorry, let me just copy and paste it into my notes so we've got that sorted. Oh, where's my thing gone? Okay. That's not going to work. Right. What is different about this one compared to the other one? Sorry, I'm not looking, so I'm asking you to do something, and then I'm not paying any attention. Right, what's different to this one compared to the other ones that we've been doing? Right. Yeah, exactly. So, right, are we all paying attention? Because last time when I was teaching at the beginning, I then had lots of people making notes that I literally said 30 seconds ago. So let's fully focus. If you need to put your laptop down or whatever, let's fully focus. I didn't print out this for you, but I've given you a sheet of paper there. All right, couple of things I want to address. One is I've already said this, but we're using exactly the same skills, Zoe, as we did before. Right? So, for instance, this is a table of values, but if I had it as a sequence of numbers, an arithmetic sequence, this numbers would look like I'd start with 7 because 7 is the first number. Remember, we've done that, yeah? Now you'll be like, but 7 isn't the first number. But 7 is the first number, look. 1 is with 7, so the first number is 7. The second number, remember going back to this is when n equals 2, when n equals 1, when n equals 3, that would be the third number. What is the second number in this pattern? Well, we actually need to use the one that is a 0 and a 6. And we go, what's next, Mia? Then it'd be 8, then it would be 9, and so on. And it's just a +1 pattern. Now, what's important for you to realise is 0, 6. What's the 0th number? 6. Doesn't make sense, does it? Right, we have a first number, we have a second number, and a third. That makes perfect sense. Right? But remember, we're going from sequences to what? What are we looking at now? It begins with F.
Oh,
Functions. Now, a function, Giovanni, is not just a pattern of numbers, it's actually some math. So with a function machine, all right, we can put any input in and get any output. We can put any, it doesn't need to have a meaning like the first number, the second number. That's why we move away from the n's to the x's, right? So 0, 6 works very well with a function. If I put 0 in, I do something to it, what comes out? 6. All right, what's the rule? Well, you're quite good at this now. Let's ignore that to start with. Let's just do what we were doing before. If it's +1, it's un equals 1n. Do we write 1n? We just write n. So I can delete the 1. And then we say, well, if n is 1, but I need 7, so I need to +6. Now, I already mentioned, you might then notice, ooh, look, the +6 is actually the number of the 0 term. That could make life easy for me. Now, you've been doing that, that's easy. Now, with your x's and y's, what you'll notice, look, is there is a gap. So, is the next number here 8? Why not? You can.
because they skipped the other.
I like the way you said it. They skipped, didn't they? They gave me the 1, but they didn't give me the 2, the 3, or the 4, but they did ask me for the 5. So I've got to figure that out. So it's 10, then 11. So actually, it's not 8, it's 11. And then -2. What's going on there? That's actually going down, backwards. So I would need to extend my table the other way and go, so -1, -2, that would be 5 and 4. Now, just because they're in that order in the table doesn't mean you have to stick with that order. So I have given you another sheet, so you can write them out in order if you like, Nathan. Alright? Does that make sense? Now, to get it correct on the computer, because we're not dealing with a sequence of numbers just, we're dealing with functions, instead of un equals n plus 6, we change this to y equals x plus 6. Means the same thing, we're just using less because we've come from a graph. So you will notice that the later ones, alright, it makes it harder by changing the order in which things happen. Feel free to write them down in an order that helps you. So I've given you that sheet to do that. Okay? Go for it.